Relative motion is how objects move relative to each other. So, for example, say we have the coordinate frame, x, y. Now, there are two objects. Let's say object A is over here, and its position vector is RA. Then object B is over here, and its position vector is RB. Now, each of these positions is given relative to the origin. But what if we wanted to know where are these positions relative to each other? Like what if we are observer A and somebody else is over here at B, and we want to know what is their actual position, but all we can tell is what their position is relative to us. So from our view, if we're at A and we're looking at B, this is how we see. And if somebody at B is looking at A, they're looking back at us, they're looking like that. So if we use the vector addition, then to get to position A, we'll have RA equals position at B plus position of A relative to B. This is RA with respect to B. So that's how to find position of A if position of B is known. Now we could go the other direction. So because B looking at A is the exact opposite of A looking at B, because B looking at A is the exact opposite of A looking at B, then RB with respect to A equals the negative of RA with respect to B. This is RB with respect to A. And we can tell this because if we know A and we're trying to find B, then we can say RB equals RA plus RB with respect to A. Because to get to B, you go to A and then to B from A. So this is RB minus RA equals RB with respect to A. And then this one here, RA minus RB equals RA with respect to B. So you can see here the signs just flip. So RA with respect to B and RB with respect to A are opposite. Same magnitude, but opposite directions. We can see that on the graph. Given that these are the positions, if we know the position, then in order to find relative velocities and accelerations, we just take the derivative. So we start with this one, RA equals RB plus RA with respect to B. Well, then to get velocity, you just take the time derivative of each one. And we'll find that VA equals VB plus VA with respect to B. Similarly for acceleration, another derivative shows us acceleration of A equals acceleration of B plus acceleration of A with respect to B. So these are the relative motion equations.